Okay, so we've got e to the 2i theta, e to the minus 2i theta, so that equals cos 2 theta plus I sine 2 theta plus cos minus 2 theta plus I sine minus 2 theta, which is cos 2 theta, I sine 2 theta plus cos 2 theta minus I sine 2 theta, which equals 2 cos 2 theta as required. Right? Okay, next bit. So we've got two series. We want C plus IS. So C plus IS. And we're going to combine if we've got the same angle. So it's 1 plus a quarter cos 2 theta plus sine 2 theta, which is e to the 2i theta, plus 16th cos 4 theta plus I sine 4 theta, which is e to the 4i theta plus. So this is a geometric series. We've got A equals 1, we've got R equals a quarter e to the 2i theta. There's infinite series, so sum to infinity equals A over 1 minus R, which is 1 over 1 minus a quarter e to the 2i theta. Multiply everything by 4. That gives me 4 over 4 take away e to the 2i theta. Okay, that wasn't too bad. Now the next bit, a little bit trickier. We've got to show the complex part. Oh, sorry, not the complex, the real part, in fact. C plus IS. We want the real part is that. Now, we know C plus IS, so we've got C plus IS. So the complex plus, the complex plus the real part, C not being complex has confused me, we know is this. Now the difficulty we've got in splitting it between a real and a complex part is the fact that our denominator is complex. So what we need to do is make our denominator real, then we can just pick out the complex part from the top or the real part from the top, whichever bit we want. So to do that, we're going to multiply top and bottom by 4 minus e to the minus 2i theta. Now it's not immediately obvious, this I don't think. Clearly if you've done some questions you'll realise, but what this is going to do is this times this will generate just a 1, which is fine, but then we're going to have 4 of these and 4 of these, and because we've got e to the 2i theta and e to the minus 2i theta, it will take us back to our original thing. We'll have this plus this, so we'll have some cos 2 thetas. Okay, so again it'll be a real part. So we get, anyway, so we get 16 minus 4 e to the minus 2i theta on top. On the bottom, we get 4 times 4 is 16, plus that times that is 1, so it's 17. And then we get minus, and we get minus 4 lots of this one, and minus 4 lots of this one. So minus 4 lots of e to the 2i theta plus e to the minus 2i theta. Okay, and that equals 16 minus 4 cos 2 theta, or cos of minus 2 theta, which is cos 2 theta, minus sine 2 theta, because it's plus sine of minus 2 theta. Apologies if I've done a step too much there. And on the bottom, we've got 17 minus 4 lots of this, and we know from the beginning that that equals this. So we've got 8 lots of cos 2 theta. Okay, almost there. Now we're looking for the real part. Okay, so C is the real part of this. So that implies C is 16. Oh, sorry. This should be I here, apologies. Right. Cos 2 theta plus I sine 2 theta, and we had a minus 2 theta, didn't we? Cos of minus 2 theta plus I sine of minus 2 theta. So 16 minus 8 cos 2 theta over 17 minus 8 cos 2 theta. Sorry, what's wrong with me? 4 there, apologies again. 4. Okay, so is that part C done? Okay, if C plus IS is real, that implies or tells us that the imaginary part is 0. So the imaginary part, S is the imaginary part, equals 4 minus 4 times minus I sine theta. So 4 sine 2 theta over the denominator, 17 minus 8 cos 2 theta. So that equals 0. So therefore, 4 sine 2 theta equals 0. Sine 2 theta equals 0. So therefore, finally, theta equals 0. Pi by 2, or pi, within the range we're given.